For over the past few years, numerous devastating storms and typhoons struck the municipality of Casiguran, Aurora. Among these are typhoons Waning and Lando. Indeed, storms and rainfall have become more catastrophic as the years progress. These gradually intensifying environmental phenomena can boil down to one common cause: climate change, which has been the defining issue of today's time as it continuously leads to extreme climatic variations and weather events throughout the world. Yes, the catastrophic events brought about by climate change compromise the entire planet, but there is a specific area wherein the phenomena are felt the most: the coasts. With coastal cities being densely populated and highly dependent on coastal resources, it is highly imperative for these areas to be protected. And this is where our study comes in. I am Julian Matthew O. Paeldon.
I am Elise Yutuc.
And I'm Gabrielle Denise M. Arjona.
And we are here to present our research entitled Determining the Vulnerability of Coastal Communities to Climate-Induced Hazards in Casiguran, Aurora, Philippines, and how it can pave the way towards coastal protection and adaptation.
Our study aims to fill in the potentially detrimental lack of sufficient vulnerability assessments regarding the risks and hazards being faced along the Philippines coastlines, specifically in Casiguran, Aurora, and its coastal barangays. Shown here is the map of the province of Aurora, and the dark blue portion is our target study location, Casiguran. It can be observed that Casiguran, Aurora really lies along the coasts of the country. In this study, we referred to the guidebook on vulnerability assessment tools for coastal ecosystems that was prepared by the Marine Environment and Resources Foundation, or MERF, and used the Coastal Integrity Vulnerability Assessment Tool, or CIVAT. It is important to note that the unit of assessment is only on a barangay level, meaning that it assumes that the processes are open for discrimination of the relative vulnerabilities. However, the limited instrumentation involved in some data like tides and sea level changes does not allow any discrimination on a barangay level.
With that being said, here is the overview of our main methodology that we utilize to conduct our study. The CIVAT assessment is done based on the physical changes on the coast, which are categorized in different criteria, namely exposure, sensitivity, and adaptive capacity, which will be further discussed later on. For the first criteria, exposure, we evaluated the rate of relative sea level change and tidal range using the criteria in the CIVAT tool. Moving on to the next criteria, in a geomorphological context, MERF defined sensitivity as the degree to which a rise in sea level or storm surge would initiate or accelerate changes such as coastal retreat and beach erosion. Here are the criteria that we utilize to measure sensitivity. For the first three criteria, we utilized Google Earth as our data source. Since the coastal landform and beach vegetations were observable data, we utilized a voting scheme wherein 3 of us will individually score the barangays with regards to the criteria. The individual scores were then averaged and evaluated based on the criteria to yield the final scores for those categories. Meanwhile, the data for coastal and offshore mining were collected from the government website of Aurora. Under the sensitivity criteria, there are sub-criteria specifically for coastal habitats. Here are the criteria that were considered and used for the evaluation: corals as sediment source, seagrasses as sediment source, mangroves as wave buffer, and mangroves as sediment trap.
After deriving the sensitivity and exposure measures, we then rescaled and cross-tabulated them to calculate the potential impact, which is a function of sensitivity and exposure. Here is an overview on the potential impact calculation. To take into account the criteria that we didn't satisfy in the full list given in the guidebook, the cross-tabulation method, or the CTM, began with rescaling the scores obtained respectively for the exposure and sensitivity categories into low, medium, or or high measures, which are denoted by L, M, or H. Now here's the CIVAT rescaling guide. The total sensitivity or exposure measures were evaluated based on the number of criteria that we were able to satisfy. As you can see, the ranges that depict a certain rating of low, medium, or high varies depending on the number of criteria satisfied. Through the CTM, the rescaled exposure and sensitivity measures of each barangay was then cross-tabulated such that their combination corresponded to a certain degree of potential impact.
For the next criteria, adaptive capacity, the criteria assessed were guidelines regarding the easement or setback zone, guidelines on coastal structures, and types of coastal development. Meanwhile, mangroves, seagrasses, and corals were also assessed for the adaptive capacity for coastal habitats. In summary, here is the full list of our data sources to satisfy all the criteria that we've mentioned. Once the adaptive capacity is measured, we then rescaled and cross-tabulated it with the potential impact to calculate the overall vulnerability. All the above steps were repeated for each of the barangays covered by the study. Lastly, the overall vulnerability measures were then depicted in vulnerability maps, which were generated through GIS, specifically QGIS.
With the methodology that we have mentioned, here are the results that were yielded. For exposure, we evaluated the data that we gathered with the criteria shown below. The data that we have gathered for sea level change and tidal range were about 1.47 centimeters per year and 0.70 meters respectively. The sea level change criteria had a score of 4, while tidal range was scored with a 2. And since these measures were the same for each of the coastal barangays, it was revealed that the barangays of Casiguran were moderately exposed to coastal hazards, as reflected in the map being shown.
Moving on to sensitivity. The results revealed that among the 12 coastal barangays in Casiguran, Aurora, barangays Kulat and San Ildefonso are less sensitive compared to the rest. While most of the barangays are at a medium sensitivity, the 2 barangays mentioned had a low sensitivity score. The barangays that are considered to be of low sensitivity have a rocky coastal area with beach rocks or a cliff coast. Meanwhile, those under medium sensitivity were described through low cliffs, beaches that have cobbles or gravel, and fringed with mangroves. After cross-tabulating the exposure and sensitivity measures, it was shown that the potential impact measures were identical to sensitivity, as seen in the map, since the exposure measures were uniform for all of the coastal barangays studied. With this, the potential impact depended only on the sensitivity measures.
As for the adaptive capacity measures, results show that 10 out of 12 barangays that were studied are highly adaptive to coastal threats. The surrounding large mangrove canopies along the municipality conforms to the claim that mangrove diversity in the Philippines is significantly high. However, the municipality scored low in the viability of coral reefs as a sediment source, which shows the critical need for the preservation of coral reefs in the area to be able to endure possible damaging hazards.
After cross-tabulating the potential impact and adaptive capacity measures, the municipality of Casiguran, Aurora was found to have a generally low measure of overall vulnerability against coastal risks and hazards. As shown in the vulnerability map, barangays Dibet and Esteves are discovered to be moderately vulnerable, while the rest of the coastal barangays have low susceptibility against natural threats. These could be attributed to the fact that the area is predominantly rural and is surrounded by large areas of vegetation along the coast. However, despite these measures, there are still specific criteria that need to be given attention. Criteria regarding coastal habitats were seen to have the most high sensitivity and low adaptive capacity scores. Thus, the appropriate intervention should be enforced in order to preserve the viability of these coastal ecosystems, considering how crucial their role is in coastal protection. It is also important to highlight that the proper implementation of the CLUP or zoning guidelines, together with the preservation of beach vegetation, are vital measures in maintaining coastal integrity.
Moreover, results from the study hold great contributions to general policy making. For example, the case of the controversial establishment of the Aurora Pacific Economic Zone, which is centered mainly on barangays Dibet and Esteves. And it is important to note that these two areas showed moderate vulnerability to climate-induced hazards. Situations such as this highlight how vital coastal assessments are, especially when dealing with industrialization, given how crucial the role of vegetation is in coastal resiliency. That is all. Thank you.